Welcome again in next ADAS video. The main target is to explain how to use simple vibration meter ADAS Vibrio for vibration analysis. Many people think that successful vibration analysis is possible only with a high-level analyzer which contains a huge number of available measurement functions. But it is absolutely not true. Please trust me that 80% of analysis you can do with simple vibration meter. What do you have to do for that? Firstly, you must define the measurement points on the machine. It is good to use one point for each bearing in radial direction. It means perpendicular to shaft, and one point on axial direction. For horizontal shaft, use the direction between horizontal and vertical axes. For vertical shaft, use any radial direction. For standard machine like motor plus, for example, pump, you get 5 points. The next step is the preparation of measurement points. Good preparation ensures repeatability of measurements. It is key factor for vibration diagnostics. It is critical mainly for bearing condition measurement. The standard way is using of pads. They are glued to the machine and ensures correct signal transmission path to the sensor. The readings are repeatable, and this property is very important. When the sensor is mounted to not flat surface, then it swings, and also the measured value swings. When the sensor is mounted to powder, then the value is stable. You can make a simple test. Take several acceleration measurements on unprepared point. Always measure the value, then take accelerometer away and mount it back again. You will be surprised how different the readings are, and it is wrong. You must be able to repeat the readings with the same results. You can take first reading once you prepare your points. Take two values from each point. The velocity value in millimeters per second or inch per second and the acceleration value in g. The velocity value is measured in frequency range from 10 to 1000 Hz. It gives us the information about mechanical failures like unbalance, misalignment and looseness. The acceleration value is measured from 500 Hz to 16 kHz. It contains information about roller bearing condition. The ADAS Vibrio displays both values on first screen. Write the values on paper table or use the Microsoft Excel or use the ADAS DDS software, which is free for Vibrio readings. The DDS software you can download from ADAS website. The first question is whether the values are low or high. You can use the ISO 10816 standard, where you find the table with velocity limit values. Or you can use the ADAS limits table. You can find them in Vibrio manual. You can see that ADAS limits depends on the speed. For example, if your machine speed is 1500 RPM, then the alarm limit, the red line, is 3 mm per second for velocity and 0.75 g for acceleration. When the measured value exceeds the limit, then we need to say what the failure is. If the acceleration value is high, then the bearing condition is not good. You can confirm this information on the screen with time signal. You should find regular shocks there. If the velocity value is high, then you need to look at the spectrum screen. If the spectrum contains only one high line on the speed frequency, then the unbalance is the failure. For example, on this spectrum is only one high line on 25 Hz. When you multiply the 25 times 60, then you obtain 1500 RPM. If the speed is 1500 RPM, then unbalance is the failure. The unbalance can be mechanical. Then you will do the balancing job. Or the imbalance can be electrical. Of course, only for motors. When electrical failure exists, then it also generates only one spectrum line on speed frequency. Fortunately, you can do simple test. Watch the velocity value and switch the motor off. If the velocity value decreases together with speed decreasing, then the mechanical unbalance is the failure. When the velocity promptly drops to almost zero, then it is electrical failure. In this case, the value can increase in the beginning and then drops. It is also normal. If the spectrum contains the speed line and the multiplies, we call them harmonics, then the failure is looseness or misalignment. If the axial velocity value is much lower than radial values, for example less than 30% of radial value, then the failure is looseness. In this case, we recommend to take readings on all machine feet. You can do it without parts. The velocity measurement on low frequencies is not so sensitive as high frequency acceleration reading. You should find one foot where the value is higher than on other feet. That is the point with looseness failure. Usually it is broken anchor bolt. If the axial velocity value is similar or higher than radial value, then the failure is misalignment and you should do the alignment job. In the end of this video, I want to mention the special failure. It is resonance. It looks like unbalance. Only one speed line is in the spectrum, but balancing has very small effect. The real reason is that the natural frequency of machine foundation is near the speed frequency. How to recognize it? Do the measurement of velocity on the foundation. If the values are small on the ends and high in the middle, then the resonance is the failure. Usually you need to reinforce the foundation. In other words, you need to change its natural frequency. For successful diagnostic, you should take readings regularly. The recommended time between readings should not be longer than 1 month. We trust you that with so simple vibrometer as Adash Vibrio is, you will be able to convince your management that vibration analyses are very useful and that it can save significant money. Thanks for watching.